And welcome to Chapter 4's Lesson 4.4, Geometric Distribution. Get to know the new terminology for this lesson. Click on each of the words, learn its definition and meaning. When you are ready, click Continue. For a geometric experiment, it must have these three characteristics. First, there are one or more Bernoulli trials. It just means a trial that you can repeat under the same circumstances. And in fact, all of the results are failures except the last one, which means you can keep going and going and going and going until you have a success. So maybe you're throwing darts and the experiment is how long will it take you before you hit a bullseye? So you're going to go until you hit a bullseye. So in theory, the number of trials could go on forever. There must be at least one trial, but it could go on forever. The probability of success is still going to be P. The probability of a failure is going to be Q. And of course, P plus Q equals 1. The X is the number of independent trials until your success. So you go, go, go until you get a success and then you stop. When using geometric, it has its own mathematics behind the scene. Let's assume that the probability of a defective computer component is 0.2, in other words, 2%. Components are randomly selected, and we're going to find the probability that the first defect is caused by the 7th component tested. How many components do we expect to test until the one is found to be defective? We're going to let our capital X be the number of computer components tested until the first defect. Little x will take on the values 1, 2, 3, 4. And remember, because this is geometric, in theory, we can keep going and going and going. We do know P is 0.02. We're going to find the mean, the variance, the standard deviation. The cool part about this is really the only information we need is P and Q and X. And all of those things are pretty much given to us. The mean is going to be 1 over P. P is given to us as 0.02, so the mean, 1 over 0.02, is 50. The variance is 1 over P times 1 over P minus 1. Now, 1 over P minus 1 is not Q. It's not the same thing. But we do know what 1 over P is. That was 50. That's the mean. And 50 minus 1 is 49. So the variance is going to be 50 times 49, or 2,450. The standard deviation is the square root of the variance. So we need the square root of 2450. And that gives us 49. Well, 49.4975. So we'll just say 49 if we're rounding. We expect the standard deviation to be 49 parts. We expect the average that we're going to have to look through is 50. Now let's actually find the probability of finding it on that 7th component. The probability using geometric is P times Q to the X minus 1. So P is the success times Q 7 minus 1 times, because we did the success once and the 6 others were failures. So 0.2 times 0.98 to the 6th is 0.0177. So the probability of finding it on the 7th tested is about 1%, 1.77% of the time we will find it on the 7th try. We have two geometric distribution functions. We have the geomet PDF and geomet CDF. It does depend on what you're looking for. If you're looking for an exact amount, like we need to ask 10 people, then you would use PDF. If we ask 10 or fewer people, then you're going to use cumulative distribution function, so CDF. So it depends on what your problem is, which one you're going to use. So let's see it. I'm going to say that my x value is 10, that my probability is about a 1 in 78 for this problem, and I want to know what is the probability that the number of people I'll ask is 10 until they get a positive response. So second, vars, which is our distribution area, and you can scroll down, 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 but it's actually faster if you go up and go to the end. And geometric PDF is E, geometric CDF is F. So if you remember with our location, you can use the alpha to get to them. So I'm going to go ahead and use alpha. I'm going to say second vars alpha E, and that's going to give me the geometric PDF. My p-value was 1 in 78, so 1 divided by 78. There's no rule that says I can't put some math in here. And my x value was 10. 0.0114 is the probability that it will take me 10 people before I get a positive value. Now let's try again, but this time we'll have to ask 20 people. What's the probability that will take me 20 people to get a final yes? So second vars alpha E, and I'm going to go ahead and leave my 1 over 78 there, but I'm going to change my x value to 20. This time I get 0.01. What if I want to say, what's the probability that will take me at most than 5 people? Now if it says at most, I need to use CDF. So second vars alpha F will get me to geometric CDF. My probability is exactly the same. My x value this time, I said at most 5. So my x value is 5. And it's 0.625. So what this does is it does the calculation for the 0, if x was 0, if x was 1, if x was 2, if x was 3, if x was 4, and if x was 5, and adds those values up for us. Cumulative. If I say, what's the probability that I need to ask more than 7 people? Well, I can only do less than with the CDF, so I'm going to have to say 1 minus the geometric CDF to be able to get if I'm going to have to ask more than 7 people. So I'm saying 1 minus, and then I'm going to go ahead and go back to my CDF function and change the 5 value to a 7. And this is the likelihood I'll have to ask more than 7 people to get a response that is positive. 0.9136. So if I have to ask for an exact, what it will take to ask 10 people, what's the likelihood that I will get a yes on that 10th person, then you're going to use PDF. If it's, can I ask fewer than 6 to get a response, then you're going to use geometric CDF. And if you have a question that's posed, if I have to ask more than a certain amount of people, then you would use 1 minus geometric CDF. Okay, that's it for this lesson on the TI-84. Until next time, be seeing you. You've reached the end of this lesson.